Hello and welcome. I'm Bill Wake. We're on a fairly new project to create a tool that can help us do analysis of music. In particular, I've got a bunch of tunes and I'd like to compare them and understand kind of the relationships between them, how they might have evolved over time, and so on. We did something yesterday called a Parsons code, and basically it captures the up and down motion or rhythm of, I guess, motion of a melody. So if it goes up, 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 and then down, 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 it looks kind of like a little triangle going up and then down. And, conversely for whatever. So you get a little bit of a signature that sort of says these two tunes might be similar because they both go up three notes and down three notes. It won't be the same three notes, probably, but it gives us some indication that there's a similarity there. Now, to do this, yesterday we did this, and the core of it is very easy. It's just kind of like compare the next note to the current note and decide if you're going up, down, or the same, and spit out either U, D, or R. R is for repeat if they're the same. U for up and down, of course. And we did this. We created the Parsons code. We kind of extracted out a notes class and then a note class. And the more I think about it, like the worse it gets. So I made the mistake. Let's see if it's done here. I updated my iPhone and it's updating my Xcode now. I accepted an update for who knows why. Okay, but I think there's enough going on to talk about that. That's okay. So the notion of a note in music. All right, so let's take this this one. I don't think we can see what I'm talking about there. Well, here I got an example. Okay. What happens in kind of most traditional music is you have what's called a key signature, and it's either sharps, flats, or nothing, and some kind of odd key signatures can be both, but the normal ones are either 0 through 7 sharps or flats, and they sort of give you an implicit thing that says this note, whenever you see it, it should be sharped. So that top line is an F. And so every time you see an F, whether it's up here or down here on the bottom space or somewhere else, wherever it is, by default, it's an F sharp. So here we have D, E, and this is F sharp, even though it if you just didn't know the key signature, you'd say it's an F, but it's really an F sharp. And the key signature makes that happen implicitly. Sometimes in your notation, like here, D, E, F, D, E, F, well, it's really F sharp again. So F sharp, this is implicit because of the key signature. And the K, G there says key of G, which corresponds to 1 sharp. And the rule for sharps is take the rightmost sharp, go up a half a step. So F sharp, the key is going to be G, is 1/2 step higher. Okay, and so when I see D, E, F sharp, D, E, F, I know it's D, E, F sharp because of the sharp. And you don't have to say anything extra. This implies. Now, if what happened is somebody might decide they need an F natural, so they don't raise it a half a step. I should probably get a piano keyboard picture here with what we're doing. It's really a crash course if you don't have any familiarity with music, but I could say I would like you to play this one F natural, so down a half a step, canceling out of this. I'd write a little natural, which is kind of like a square with a line on the top and a line on the bottom. I don't think I have one kicking around anywhere, but that would cancel it out. And you can also write F sharps and so on. Okay, now we're gonna. Sorry. So you could cancel them out. You can also have explicit sharps. I could even write a sharp in front of it, and it would be guaranteed to be an F sharp, even though the key signature already did it. But it's kind of a different sense. It's kind of saying like, oh, I promise this is really an F sharp. It's not double sharped or anything because I've got one there and now a new one. It's just saying I concretely want F sharp. um, and goes from there. So, whoops. Uh, so what I think I need to do is I need to account for a couple things. One is these. Well, there's the notion of plain notes. Let's see if I can. There we go. Plain notes. Okay. C, D, E, F. Okay. Then there's a notion of um, notes. I don't think I have a term for this. Affected by the key signature. Okay. And in our example in G, C, D, E, well, F sharp is implicit. Okay, so the same three notes C, D, E, F in the key of G, F sharp, key of G, the F sharp is the 1 sharp and it's always implicit. Even if you told me it was an F in the notation down here, you tell me it's an F, but because we're in the key of G, I know that means it's implicit. Okay, I'm going to say it this way. And then the third category, notes with explicit accidentals. Okay, and maybe I'm in the key of C and I say C sharp and I say D flat. I won't look up the formal flat signature. Okay, and there's actually a double sharp that looks kind of like an X with some dots. Okay, the F sharp might still be implicit in the key of G, but they're made explicit when we do them. And I think I need both these. I don't think I need this because I can always the key signature. I can always say the key signature is C, which is 0 flats, 0 sharps, and just sort of the natural beginning point. And then this one, I think these two can merge. They're kind of the same. Same as key signature of C, no sharps or flats. Okay. But these explicit accidentals, we're going to need to do that. Okay. So, all right, let's see. I think I got my system back. All right. Today let's see. Let me bring this up again. Oh, you're not going to do that for me. Let's see if I can open this. Ugh. Okay. Sim. I don't know. Something about these. Okay, that looks better. All right. So I think we have notes already that sort of do this. We need to do this, and they both count. Now, what we did, which is primitive, but right now we just say, oh, we're going to keep track of the MIDI note numbers, but that is not really what the note is. It's fine for comparing the note value because there's sort of an effective note. Let me go back here. This let's take C double sharp. Okay, so it's like C sharp sharp. What this C sharp goes up half a step from C, and then C sharp sharp goes up a whole step from C. Well, there's already a note there called D that's a whole step above D. So these two notes have the same name. Well, they have different names, but they reference the same note. Now, in some instruments, there's a subtle difference between a double sharp and a natural note. But like if you're on a piano or, general synthesizer, keyboardy kind of things, they don't tend to use the tunings that let you distinguish those. A fiddler might. They might pick a slightly different tone that fits the harmonics of the of the key you're in or whatever. But on a piano, C sharp sharp is the same as D. And so if I represent them by their number, like I don't know if a D is a C sharp sharp is 62, but C sharp sharp and D mean different things from a music theory point of view. So saying my tune is C sharp sharp implies that it's still a version of C, and we may need to know that in for some purposes. Okay, so I think this view is very innocent. The other thing is, this view is also it also assumes we're using this ABC notation, which says lowest octave, or the bottom octave on the treble clef is capital letters, and the next octave up is lowercase letters. That I really need to distinguish ABC from how I'm representing stuff. So I don't think it affects our parsing code if we do it right, but it definitely affects what we're looking at. We may need to say, oh, encode it from ABC style. That's fine to me. But the string itself, or the thing we're encoding, should be notes. And I mean, our parsing code assumes notes. It just compares, give me the notes and I'll compare them less than, equal, or whatever. But the tests, let's see, tests, whoops, let's do the notes test. Oh, I don't really have a parsons test. This should really be parsons code test. Let's change that. Okay, so each of these, they assume they can do notes with the letters like this, lowercase, uppercase, whatever. That's not really right. I mean, that's assuming this ABC notation, and I don't want to do that. I want to split that up. So I don't know. I may have a whole project today just doing that, even though we've only written 2 classes, 2 real classes, 3 real classes. Okay. The other thing I did was I poked around and figured out why I don't know. I couldn't create my files in the shared folder here. It's somehow the target membership stuff, it was not defaulting to the right thing. So now that is the case, it puts them in the right library. And I made a separate shared test library that we can run by itself. I don't really have any user interface, so I don't really need these other tests. There's no iOS specific code at this point. Well, we'll deal with that later. Okay. And let's deal with note. So I think notes is actually okay. It's just a list of notes. It's a list of note, an array of note that acts like a sequence. And I think we can. Okay, let's make sure tests run. And check that in just to deal with that refactoring. Okay, well, it'll take a minute, I guess. All right, but anyway, notes is sort of a trimmed down view of just the notes of a song without worrying about rhythms or any of that stuff. And it just acts like a sequence, and you can get a sequence of notes and do something. And that's what those tests relied on. But for each of these, I don't think I should really produce them from strings. Okay, so this was test refactor. Parsons code tests. It's taking a moment. Okay. So this, yeah, the part I object to is this. I think we need to think about how those get done. Okay, let me close some junk. Let's see what our to-do says we're doing. Make note understand octaves. Make note understand this. Make note understand key. Okay, I guess that can go after that. Okay. And really, boy, I think I've just got to separate out this Parsons code thing. There's something. I'm sorry, the ABC thing. So somehow, like, this is really an ABC string, and we ought to be parsing it as an ABC string. So let me. Well, I don't know. I want to push this in. I'm thinking, this is kind of a structural change. We're not adding functionality. So I'm going to do it in a slightly slower way just to kind of be careful. Okay, and let's get note and notes. Whoops. And note. Okay. So what I'd like to do here is I'm going to say there's such a thing as an ABC parser, and an ABC parser can map a note to map a string to a note. And then once we can do that, I think I want to modify note to reflect the two ways we talked about, either key signature or explicit, and handle that. Now we can add optional arguments and stuff like that. For now, I think that'll be fine. Okay, so let's go to the test. All right, so I'm saying notes of something. What I really want to do is say it's not notes.map. I'm saying I give the ABC parser a string of some sort, and it should come back with the notes array full of note. Okay, so let's say self.notes equals ABC parser new one dot notes for string. Oof. Notes. Okay, and then that thing doesn't exist. Let's create it. ABC parser, and it has a notes function. Notes given a string. Notes string of string. I don't know. What does it produce? Well, it produces notes. And the way it does it is going to be this. I guess it produces array of note for now. Okay, with this code. return note string dot map of note dot string of that. Okay. Okay. Now this goes away, and this should just work. I mean, it's kind of a weird way to operate. This refactoring is like it's seeing a class that was never there and going like, boop, it should exist, and pulling it out and making it exist. I don't know, preparing editor functionality. Like, hey, just run my tests. Although I think I may have updated Xcode to support iOS 16, so that may be a good thing. But anyway, we've extracted this class out, and my hope is that we can then move this up a step and let our notes be the ABC parser thing, and never let this thing take the notes. Okay, are you gonna run? I can't tell if it's run or not. Test completed. Okay. All right. So introduce ABC parser. Okay. And I suspect this is going to become something different, but we'll get there. Whoops. Okay. Now, abcparser.notes. All right. So this thing no longer knows how to create a note. It's given the notes. I think that's a good step. It's a touch weird, but it's probably a good step. Okay, now this, let's extract it out to its own file. Really? Okay, let's check this. ABC parser is in this project. That's a good thing. Oh, it's catching up. Okay, let's try our test. Okay, extract file ABC parser. And I would like for ABC parser to become its own thing at some point if I really flesh it out all the way. We shall see. Okay, so now I've got ABC parser. I can say, all right, let's find notes. All right, notes, I want to move its string. I want it to take an array of note. All right, so we'll do it in a non-harmful way. We'll provide two inits. Okay. Nobody's calling this one yet, but I want them to start doing that. So what I'm going to do is create a notes in my test based on the parser. Okay, so where's tests? Parsons code. Yeah, that should really be tests. Oh, I think my rename will actually do that for me. Okay. So we added note init to notes and rename Parsons code tests.swift. Okay, now in Parsons code test, I'm going to say let notes equal notes of AbcParser dot notes for this. And this is notes now. Okay, and let's just check this test. All right, that's green. This preparing editor functionality seems to have turned off my mic or my sound. Yeah, it's on. Okay. All right, so you can see why I split out the constructor, because I've got a bunch of these. I mean, it's not so many, but I just wanted to fix them one at a time. So let's do that. This is going to be pretty common. Okay. Now, why don't I trust it? You're supposed to put green checks here. Are you doing that? Let's just clear test results and make sure. Okay, good. All right. Yeah, you know what? We can make this even simpler. Okay, I'll do this and then we'll fix that. We could just let notes return a notes object. I think that would actually be better. We shouldn't be passing representations around if we can avoid it. Wait a minute. Oh, Parsons code test. Okay, there's a bunch. Good. Test going up and down. What? Okay. Okay, so now we've got um, make test call parser, which I think is actually a good thing. I think we'll push the. Let's see. Let's take care of notes first. Nobody's calling this now, I don't think. Okay, so we'll take this one out. Now nobody knows strings in this class at all, which is good. Okay, now the parser, let's return notes here. Okay, and that affects our test. Doesn't affect that, fortunately. Okay, so we need to take the notes off of this. One more. Okay, I'm happy there. What's going on there? I will do this later. it may mess up something in my config, so I don't want to screw with it now. Okay. Well, what we did was introduce AbcParser, make it produce notes. Okay, I think we're still kind of in that process. Okay, I'm happier there. I almost could create it with that input text. We'll do that some other time, I think. But yeah, just kind of noticing, like, at some point we're going to want to read a whole ABC file, and notes is just kind of one thing we might want to pull out of it. It might have a whole structure to what it produces. Okay, that's notes. Now let's go to note. Okay, note. Right now it's got this string to MIDI note number. Okay, so again, I think it's the AbcParser's job to know that A maps to the note A in this particular octave. Okay, so let's introduce octaves as an idea. Okay, so the note name, well, I'm gonna let octave be an integer, and I'm gonna default it. To 4. 4 is not arbitrary. It is the default object for middle C, the default octave for middle C. Okay. Note value equals that. And self.octave equals octave. Okay, now I think this, okay, octave, well, these are all, so the MIDI goes down here. This is 0. Let's see, there should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which means actually -1 is an actual reasonable value. Okay, so int is not out of question. Okay. All right. So okay, I haven't broken anything yet, I don't think. Let's make the parser. I'm gonna put this up here as our focus. It really should parse notes. Okay, so if the parser parsed note, and I guess it's still a string, note. Okay. That corresponds to this, I think. Note of string of note string. This becomes note. Okay, so note string is being mapped to its characters. We rep it back in a string to put it back in here. This is kind of arbitrary stuff you do with characters because they're just a weird, well, they're complex. It's like a character versus the bytes in it are two totally separate things, and you kind of have to worry about that. Okay. This maps to, okay, that should just work. Okay. Now, I want to bring in the note stuff. So if it's a letter A through G, actually if it's greater than or equal, well, if it's greater than or equal to A, it's in this 5th octave, and if it's less than or equal, it's in the 4th octave. So let's keep track of that. I promise this is going somewhere. Okay. Oh, this doesn't need a string here. Make sure that's true. Do I want the character? If note string, can I do sub dot first? Is less than or equal to G. Well, let's do it this way. Let octave equal, if note string is less than or equal to G, then 4 else 5. If note is less than or equal to G, 4 else 5, and I'm going to return this. Okay, this should be good still. Notice we're not using the octave in the other thing yet, but we've put stuff in place for it. Okay. Now I've got a note name and a string. Okay. I'm going to say the note value. Let's see. What do I want to do? I'm going to modify this. I'm going to say it's 60 plus that. And I'm going to take 60 off of each one of these. 9, 11, 0, 2. Okay. 0, 2, 4, 5, 7, 9, 11, 12 plus 2 plus 4 plus 5 plus 7 plus 9 plus 11. Okay. Okay, so I'm not changing anything in how the computation goes. Go. Well, apparently I am. Note to MIDI. Oh, wait a minute. What happened there? Oh, that's the L0. Yeah, I do want a 0 there somehow. We'll fix the names. Equals this. Otherwise, we're going to return a 0. Okay, is that going to work? Nil is the only value permitted in an initializer. Oh, yeah. Well, maybe I can just do this. Let node index equal. Note value equals that. Else, note value equals that. Okay. So we switch notes to base off the octave. Fourth octave. Okay. And then this is note index. And we know it's not nil because we just checked it. Okay, let's make sure that's all right. Okay. Node index index is nil, goes to 0, else goes to this. Whoops. Result, wait. That. And I really would like that on the same line. Okay. Okay. Notes. Check for out of range values. Okay, we're still playing around with the octave stuff. Okay, now I want to do one more change. Octave is that. Okay. I want to say note name dot first. That's okay, I guess. I want to uppercase the note. Is that legit here? Yeah, I choose the octave. Okay, we need to base off the octave first. Okay, so the 60 is really octave times 12. Well, octave plus 1 times 12. Plus note index. Okay. That says we're already basing on the proper octave based on the octave. So I think these two should go to the same thing. They should go to 9, 11. Whoops. I put the order different, didn't I? A goes to 9. Well, C goes to 0. D goes to 2, to 4, to 5, to 7, 9, and 11. And I don't know, we'll put these in a musical order. Okay, so these are identical. 0, 2, 4, 5, 7, 9, 11. All right, this should still work. I keep saying that, and it keeps not working. Okay, what did I do? Is correct. They came out too low. Oh, do I pass? I don't do the right thing in the test. Note test. MIDI note number. Right. I need to be explicit on the octave. Okay, so this is these are all octave 4. These are all octave 5. And these don't matter, but okay, and now this needs to take the octave, and we need to make note with the octave. Okay. Slowly, slowly, we're getting there. All right, now I've got these two things that are identical. This is really, I could really say two upper of note name, but instead I'm going to say, just give me the uppercase version. All right, so I'm going to say to upper, and here, to upper. Oh, come on. Uppercased. Okay. Uppercased. All right, so now I'm passing in the uppercase letter to the octave. I've already looked at it to decide. I'm sorry, passing it to the note. I've already looked at it to decide. This should still pass. All right, and this can go away because I'm only passing uppercase letters. Of course, I'm not doing that here, am I? Oh. Okay. So, pass uppercase letters to note, but with the right octave. Okay. Now, okay, is that, why are you saying something's wrong? Okay. Good. All right. So our note now is simpler. It tracks the octave. It tracks the note value. I think we need the note name still. We can't get rid of that. It doesn't matter for now. Is that true? Yeah, it's true. It doesn't matter for now. Nobody's going to look at that, but we need to know it. If anybody ever asks the note name, we need to be able to say the given note name. And I think we need to be able to say the effective note name as well. The effective note is right. I think somehow we want to find out both the name and the effective note are different things. If we have once we have the key stuff in here, we don't yet. But if the key is G and the note name here is F, then the effective note is F sharp, and that's okay. All right. Let's store the note name, and that'll be fine. Maybe it's the parser's job. I don't know. Okay, let note name be of type string, and we'll just save whatever they gave us. Okay. This. That is good. Okay. Where do we want to extend next? I think, have we done this? Yes, I think we have. Produce nodes. Okay, now we want to make note, understand these types. Okay. Tell you what, I think what we're talking about here, I think I need a AbcParser test. Okay. Let's check something we've already done just to kind of verify that. I think we'll take a variation on this. And I'm just going to check a little bit. I guess I could check C, B, A, C, B. Okay. And I want to assert well, notes. He's a sequence. I don't know if my XCT test will compare sequences. XCT assert equal. Let's try notes versus the array note a. Sorry. Well, let's put these. Note C octave 5, note B octave 5, note A octave 4, note C octave 4. Let's make this a G. Note G octave 4. Global function requires note conform to equatable. That seems reasonable. Can I convert notes to, can I say array of sequence? Yeah. Wait a minute. AbcParser should be in shared tests. Okay. Let's just take that for what it is. Okay. Notes parsed correctly. All right. Now, These, I don't think these tests are valid anymore. I think we're committed to a letter A through G. The parser test covers that. And I think we'll do that. Okay. I'm going to say 0 for non-note letters. Okay. Mostly we did that. Okay. Now the note. Note. Okay. I think the thing is you can have accidentals. So I think the parser test note with no accidentals. Note for C. Note should be equal to note C5. But I want to add something to it. I want to add the accidentals. The accidental I'm going to add is default. Sorry, that doesn't go here. It goes here. Okay, and I'm making up default. Okay. We don't know what it is. It's not an int. Okay, so note. I'm going to make an accidental enum. Maybe default's not the right word. Key. In key. I think that might be a good name. Okay, and so here, call this in key, and then our note constructor doesn't take that, but we can define it for now. Accidental is an accidental equals dot in key. Okay. So nobody's going to know the difference yet. Cannot find type accidental in scope. Okay. Let's see if this works. No. Okay. Extra argument in call. Let's try this one. Note. This implicit thing is maybe getting me. Sorry, note. Oh. No, that should have worked. Okay. I guess I can't default it. Okay, so let's let it tell us where these go. Right, and right, and now my notes probably need some alignment. Okay. See if we got them all. Nope. Note number. Okay. Add accidentals to notes. All right, now let's let note remember it's accidental. And notice I'm saying there isn't one in this case, and that's fine. Accidental is type accidental. Okay. And I need to store it. Okay, now, all right, I think, yeah, we have some work to do here. So we're going to go to the ABC spec and figure out how to specify accidentals is what we're going to do. And once we know that, we're going to make the parser understand, well, first we're going to get what they all are. Let's add them. Okay. Accidental in key. You could be double sharp. I don't know. It makes sense to me to go double flat, flat, natural, sharp, double sharp. Okay. Those are the possibilities we have in here anyway. In principle, you could keep going, but like I said yesterday, nobody does as far as I know. I mean, you can probably come up with something 20th century, but not really before, probably. No folk tunes. Okay. These are the possibilities. Nobody should mind that. They're just not using it. Okay. List all accidentals. Okay. We've been going a while, so let's go ahead and take a break. Just maybe a 3-minute break, get a drink, whatever, and we'll come back and start parsing the rest of these accidentals. All right, welcome back. Let's see. As I looked at this, I noticed this now is not accurate. It's really, this is really like the half steps above C. I'm going to call it that. Whoops. Okay. And it really is back to an int. This, yeah, I think that's okay. Not sure this is pulling its weight anymore. Pull it down here. Accidental may migrate. Okay. All right. Okay, I opened up the ABC standard. Let's find where notes, pitch, accidentals. Okay. Arrow equals an underscore, note a sharp, natural, or flat, and double sharps and double flats. Okay. So what that tells me is if I have arrow, arrow, C, I should get a C double sharp. Okay, so let's make that happen. Well, and my question is how we want the parser to work. Um, all right, let's get tested and then we can straighten that out. Okay, notes with no accidentals. Yeah, okay. Okay, so we're going to take AbcParser dot note and then something, and it should be equal to note of something, and we'll just keep the octave the same. Okay, so if I have arrow C, that should be the same as C double sharp. Well, I said I would do flats to sharps. Let's do that. Double flat 4. Okay. This should fail. Boy, in key is not really quite right either. Okay, what's going on? I don't know why it's not running this. There it goes. Okay, yeah, that fails. Good. TuneSim.node. That tells me we could benefit from a debug print thing here. Let's do that. Extension note is debug custom debug string convertible. Yeah, not the thing you might expect. A textual instance. Yeah, debug description of string. Okay. Oh, it did offer. Okay, I was expecting it to offer to do this. Good. Okay. Let's say this is note. Sorry, it's a string note. Well, we don't even need that maybe. It is, let's take the note name. Note name. And then accidental. Okay, well, let's put it in here. I don't think we want to do it this way. And octave. And actually, this is usually written like this. No spaces. Okay. We're just getting a better error message, I hope. Underscore C in key 5 is not equal to C double flat 4. That's true. I'm gonna let's make our enum talk to. I mean, we want to get this nice. Okay, so let's make this thing also a well, it's kind of usual. Using extensions is not a bad thing for this. So extension accidental is custom debug string convertible. And give me a stub. And the code is, let's switch of self I forget, do you do it like this? Case dot in key. Oh, I think it'll tell me the rest if I wait. It'll provide them maybe. Switch must be exhaustive. Add missing cases. Yes. Okay. Cool. All right. So for this one, let's just return empty for now. Double flat, return, and I'm going to go find that. Where is that thing? Emoji and symbols. If I hit that, it doesn't do that though. Okay. Got music. Yeah. Musical symbols. Okay. There's double flat. Oh, is that double sharp? No. Oh, there it is. Okay, so case flat. Get the right one. Okay, this one we will leave empty for now. Natural. We have that. Sharp. We have that. Where's that little X guy, huh? Oh, here he is. And double sharp. Okay. Now I think that'll give us a better message. Bump bump C5 is not equal to C double flat 4. Okay. Cool. This message is a little weird. We're getting nothing after. Oh, yeah, we get nothing after it because it's in key by default. And it just passed along that. So there's something still. I don't know. If it's not in the range C to B, we just store the value, which I guess is helpful for us in this case, but it's like weird, really. The parser is supposed to do something, but I think that gives us enough to make the parser. That's enough to tell us what's going on. It should be C double flat 4. It comes up C5. Where the 5 is from is we defaulted it to 5 if it wasn't 4. That's a little weird, maybe. Okay, I want to say let's store this later. Move this down a little. If note index is nil, the octave should be, I think it's -1, 0. Yeah, these are going to be, so 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And I guess that's -1. Okay, and we'll run the tests. Okay. C-1. Okay, that's actually an improvement. And if we looked at the MIDI value, it would come up as 0. Okay. Good. That's a good failure. All right. Note now. Okay. Well. X equal is in key, and if note string starts with arrow, no, underscore, then accidental equals double flat. I guess we can break this down a little. In key. And now do we have a way to get those into the note? We do. Why is that not showing up here? Oh, a hard-coded in key. Okay, that's accidental. Okay, so if note string starts with that, well, let's make this note string in. Var note string equals note string in. The accent is double flat, and note string equals note string dot it's not a first, it's like a rest. I think, can we say drop first? 2. We will come back to this. Okay. So, all right. So we're peeling off those first 2 if they're there. Okay. If it starts with double underscore, accidental is double flat. Note string is the rest of the string after the first 2. And we look at note string dot first should be a letter. And really, okay, uppercase accidental. Yeah. We're going to keep working on this thing. I don't know. This note parser just really is bigger than it looks. All right. That worked. All right. So it started with that. Else, if... Oh, whoops. Let's put a test in. If you just have 1 underscore, it's just a flat. Okay, if that test fails, Okay, so we got a 0 because the unknown character. All right. And this needs to be an else. We can't just follow it, because if we had like 3 in a row, which is not really legal, then it would allow it, and we don't want to do that. Okay, accidental equals flat. Drop first 1 to emphasize that. All right. And we're on a roll, so let's go ahead and do the rest. Okay. If we got an equals, then it should be natural. If we got an up arrow, it should be C sharp. And I'll just keep mixing this up a little just to kind of, we have some interesting boundaries, right? A, G, B, and double sharp E. Double sharp. Okay, so we should get a natural, a sharp, or a double sharp. And let's make sure we got the right characters. Yep. Okay. Test should fail on the last 3. Now, it used to be, okay, I was going to say it reported all of them. Okay, G natural 4, good. And that looks nice. B sharp 4. And notice the sharp character kind of leans upward, and this one's more across, so it is a different character. And this one is E sharp, double sharp 4. Okay. That, now why it's marked this and that's marked red, like there's goofiness. Okay, but else if let's just copy these. One, two, three. Okay. Else if note string starts with equals, accidental is natural, skip 1. If it starts with doubles, it's double sharp, skip 2. Otherwise, if it starts with a single one, it's a sharp and skip 1. Okay. Whoa, something's messed up. Okay, this. That has too many. Guess my cutting and pasting leaves something to be desired. Okay. All right, that should work. All right, and support remaining accidentals. Okay. Now, how far I want to go down this path? This is ugly parsing to me. It's doing the job. All right, let's make sure. Okay. Let's make sure. I want. What do I want? Like, what if something's wrong? How are we gonna report it? And this is where I want to stop and consider what parsing approach I'm using. Right now, I just did kind of a linear peel off stuff kind of approach, which mostly works and maybe almost will almost work for this format. I mean, it's not. Hmm. It's hard to know. It's not like a programming language where you have lots of nested constructs and all that. This doesn't have a lot. It's got something. Yeah, this stuff. Ugh. Um, they got so many little alternatives and stuff. It's just annoying. But okay, yeah, there's no nesting there. I don't think I'm seeing a lot of nesting. I mean, every kind of trill known to man here. Not really, but there's a lot of them. Yeah, turn. I don't know. That typesetting's a little funny, a little hard to read. Okay. Um, I'm not seeing any nesting stuff, so maybe we'll just be naive. Um, yeah, yeah, yeah. Okay. Yeah, we really do have to decide, like, what happens when something's wrong. I could throw, I mean, that's kind of a traditional, like, recursive descent kind of thing. Well, anything where you're escaping some sort of deep down error condition. But these things aren't nested very deeply. I mean, strings of notes contain a note, multiple notes. That's true. But okay. I want to get. Um, this is really bass octave. Okay, what are we trying to do? I think that part is okay. Let's go back to the spec. Notes, notes, notes. Note length. We're not doing that yet. Pitch accidentals, note lengths. Okay, pitch is still. Yeah. Okay, so octaves are reached with commas. Okay, so, and notice that, no, they don't tell us that here. Oh, yeah, comma, uppercase C, comma, no, they misspoke here. Oh, C, apostrophe, comma is the same as C. Okay, so we can mix and match. Okay. And the notes. C through B. Okay. And then uppercase, well, C comma, C comma apostrophe comma is the same as C comma. Yes, that's true, because apostrophe and comma cancel out. And uppercase C quote is the same as lowercase c. So we got to make sure that happens. All right. And you can see this is already getting ugly. I think we'll do one more and then we'll reconsider our parsing. Okay, so let's test notes with octaves. All right, so I'm not going to mix and match just yet. If I have C comma, that should be the same as C in key 3. Okay, run that, should fail. C4 is not equal to C3, C comma 4, so it didn't peel off the comma. Okay, let's go to our parser. Okay, let base octave equal, I want this. And that should probably be tightened up, but let's deal with it. Okay. Now we've peeled off. We've got the note is the first. How about let note name equal this? Okay. And then this is note name dot is upper. Okay, let's do it that way. Okay, so if the note name is uppercase, then we base our octave on 4 or 5 and let octave equal base octave. Okay, and okay, maybe this is, let's just do far octave and be done with it. Okay, let's just do note string equals string of note string dot drop first 1. Okay. Now this is note name dot uppercased. Okay. The octave. Okay. If note string dot starts, well, let's do a while. It starts with a comma. Well, we're going to octave minus equals 1 and note string equals string note string dot drop first 1. And I think I'm doing this inefficiently, but I'm gonna get past it first. Okay, so while the note string starts with a comma, take out some octaves. All right. I think that's true for our test, and we can take two more, should get us down to octave 1. C, lowercase c, should be the note C in key. The octave should be 1 higher, so 2. Okay, this should pass already. All right, now let's do C, quote, quote. Can I do that? I think. So normally C starts 5. This will make it 6, 7. And we won't pass this, of course. Okay, AbcParser. Note starts with this, or note string dot starts with quote. Well, this is awkward, isn't it? I think that's accurate. Okay, and then a mixed case. Let's work from this one. And let's take the example they gave us. This, like that, should be C. Well, it's 4, goes down to 3, goes up to 4, goes down to 3. That should pass already. Okay. Handle octave notation. Okay, now what else we got going on? We're assuming this is a letter, and it's not necessarily. Okay. We just fall in and set it to 0 in the thing. I mean, that's okay, but it's a little awkward. Okay. I think I just deleted a character. Let's, oh boy. Let's pause. All right. What's going on? This notion of parsing, this is moderately complex, you know? I mean, I don't think we escape it in a way, because you have to match it, and you have to do the decisions about it. But It would be nice. I mean, we worked on the parser combinator stuff for our interpreter last couple of weeks, and I think it would be an improvement for this to separate out like matching this versus how do you handle it. And um, that that I think would be an improvement. This stuff's a little awkward. The octave stuff, like 4 and 5, just comes out of nowhere. I mean, it's not really nowhere because C4 is well defined as the um, middle C. I mean, that's a very standard kind of thing, but it sure seems arbitrary. Um, okay, I don't know what it will take either. Um, all right, let's try it. Add packages. You're gonna have this one recently? No, recently used. P combo. Let's add this package. Okay, it's a library. Good. Good. Okay. Now, AbcParser. All right, so let's go in here. So the deal is to write a parser, you're going to do it's going to take something in. Well, here you go. It takes in a slice of input and it produces a parse result, which is either success. I found some. I built some object. Excuse me. I built some object, or and here's the rest of the input, or it's a failure. Um, the index of the bad spot and the message. Okay, and normally you have to define some sort of basic parser that matches like one thing, and then you have all these kind of grammar rule things about alternatives and sequences and repetition and so on. Okay. Um, all right. So we need to write functions. Yeah, we need to write functions that look like this, basically. Okay, so let's try one. I guess it's an AbcParser. I'm going to make a note parser. We can fix names later. Note parser is a function. Okay. Array slice of character, and its result is character, and the target type is note. Okay, so if we did this job, we feed in characters. Yes, import comma. Okay, we feed in characters and we get back that stuff. Okay, so I'm also going to want a basic match parser. Readme. Okay, satisfy with an optional message and a function that does something. Okay, so let's say match, and we want to say character. And it produces a satisfy. Well, is it satisfy? Yeah, me too. Let's take this for a minute. Okay. We're going to return satisfy. And the way you satisfy is this closure if the element succeeds. Okay, so the match is $0 equals C. Okay, so if you find this character, then you satisfy it. Now, I don't think that type is right. No such module. Extraneous brace. Let's try that. No such module. Oh, let's make sure this thing is how we reference it. It's funny, it knew to put it there, and yet it can't find it. Let's see, does this package dependencies p combo? I'm just going to do a little cleanup. Oh, come on. Build. It's getting worse. If you had a JSON. Swift doc, no file or directory. That all just seems way off. Yeah, that all seems okay. P combo. This multi-project thing is kicking me. All right, this one, AbcParser, is in TuneSim and Mac OS. All right. P-combo is referenced in Project TuneSim. Target link binary with libraries 1. Okay. Acquired. Bundle resources. Target dependency. I don't think that's a target dependency. All right, let me open a recent project. Okay. Strategy. So parser definitely uses this. Here's expression parser. Let's see what it shows on the side. Okay, its target membership is BASI. That's good. And in here, package dependency p combo, BASI, build phases Link binary with libraries 1. No target dependencies. Bundle resources, whatever. Okay. That all seems arbitrary, but irrelevant. General Mac. Frameworks, libraries, and embedded is listed on general. Okay. General frameworks. And it's listed. No such modules. Search package collections. Yes. Right, it already contains it. Branch main, that's fine. Add to project TuneSim, it's already there. Add local. No. Okay. That seems like it should be finding it. Import P combo. It suggests it. It seems like if you suggest it, you ought to be able to find it. Okay, I'm going to clean again. What's this? Clean test, clean build, and I'm going to quit. Okay, let's try again. Okay. This, I guess our to-do is a little out of date. Make note, understand this. Make note, understand that. I think we're going to say explore P combo parser instead of ad hoc. Oh, come on. No such module, no such module. No such module TuneSim. Now, this is weird. Let's, I guess I can live without that. The comparison is this new function. I don't know. I'll grab this just to be there. Okay. I'm going to revert. Changes. Yes. Okay. Make sure everything builds. I thought. Okay. Now we're going to add a library. Packages recently used. P combo. Unable to load README. Branch main, add to project TuneSim. That seems okay. Let's see if he. Well, He seems like he loaded it. Okay. This should still be okay. All right. Import p combo package. Okay. And we should see it in the main project. Yep. And in this general, should show it embedded. This general, oh, it's not there. P combo package. And okay, I suspect that's all it was. Okay. Add package to all targets. Not sure that's the right word, but it'll make me look if it comes up again. Okay. I know. Oops, there was something in here not checked in. Okay, now let's try and define this thing. Still have that? Yes. Okay. And this, I think character. Is that all I need? Okay, and this one, let's just return dot failure 0 not used. Okay, so now a note parser hello, welcome. Okay. So we're doing a program to analyze music. We've got the notion of notes and of a single note, and we've got the notion of a parsing code, which is a sort of signature of a tune, like how much it goes up or down. And from then on, we've been splitting things up. I'm trying to parse this ABC notation to get our notes in, and I'm just putting in place a different parser approach. So you're just in time for that, I guess. All right, so what I want to do is I want to call note parser on the input string. Okay, and what I'm trying to do is replace what we have with that. So let's say accidental parser equals, okay, if you match question underscore and, well, actually we don't need to look at it, and you match another underscore, then you get a double flat. Okay, so the accidentals, if you match the two underscores in a row, you get double flat. If type could not be inferred, it's accidental dot double flat. Expected argument type V could not be inferred. still. Oh, I need to make this in braces. Needs to be a function. Okay. Else, if you just match this, no, I'm probably doing this wrong. A match optional, and this one is an optional. Match that. If we have a nil, then we only got a single flat. Otherwise, we got a double flat. We're throwing away this side, and we're just checking this side. Type of character. Let's take this off for a moment. Okay. Yeah. Or if we match an equals, then we get an accidental dot natural. Otherwise, we match an arrow. And this is kind of like the other one. Optionally match a second arrow. And if the second arrow is nil, then it was just a single sharp. Dot sharp. Otherwise, it's a double sharp. Okay, so I'm kind of building up the pieces of things. A note parser is yeah, got a little one upstairs. Okay. So the notes, that's going to match A through G, and I usually just define a kind of one of parser up here. Characters of type set of character, I think we can do. And then satisfy dollars chars dot contains $0. Okay. So if any of these characters are in there, and this then corresponds to that, one of, and I don't know, set. Gosh, I think I can do this. I'm putting them in musical order, which is a little weird, but that's the way things are. Okay, that matches one of those. It gives us the character that matches. Actually, I would just take a range. Say range. Up to but not including. Okay. Closed range. Okay. Let's say note letter. then, okay. This one is A through G. Okay. Trying to get the pieces here. And then finally, commas and ticks. Is many of, I guess, many of match, I don't know if I can say this for a set, comma and tick. I'm going to add my set one back. I know, fickle. Okay, characters. Set of character, but it produces a single character. Okay. Is that going to build? Not quite sure if Swift will recognize an array for a set. It's thinking about it anyway. Wow, what's going on there? Xcode really seems to be struggling today. I don't know if it's just stuck or just slow. I hate to reboot it yet again today, but I think I may have to. Collections join is deprecated. Build failed. Okay. Is it really that? No. Let's try that build again. Whoops, that was run tests. See, now it says 1 out of 17. It was 1 out of 22. Well, while that's thinking, okay, so my hope is we match the accidentals, we get one of these accidental things. We match a letter parser. Well, I think we could probably tell it the base octave and the letter and the base octave. That would probably be useful for later. And then the octave modifier. Um, see that we can probably. I don't know. We can probably produce a function that takes that list and converts it to an offset. Let's go down to the star. Okay. Can't return failure, returns an empty array if it doesn't apply. Okay, that'll help us. Find C in scope. Yeah. Match set has nothing to do with the real thing. Okay, how about C dot contains $0. Unexpected, non-void. Oh, this is satisfy of character. Unable to check in a reasonable time. Okay, yes, I would agree. Okay. Maybe these other fixes will help. I don't know. Maybe I should have. I didn't think that was such a bad expression. Note letter parser expected to have rain type empty. Oh, that was the declaration was screwed up. Okay. No, I still did that. Chars dot contains. I guess I could break it up. List expects one argument which cannot be explicitly ignored. Sure. Okay, so start introducing parser combinator approach. All right, so what I think I've done, I've got a couple of helper functions to match one character, a set of characters, a range of characters. If if you call the note parser, right now nobody calls it, but I define how do you find a flat. Okay, it's 1 underscore is a flat, 2 underscores is a double flat. And we can tell, we know we got the first one and the second one. We decide if it was there or not to decide if it was single or double. Same thing for the sharps. And then the accidental parser is the combination. This one, I think I should map it out to. It should produce a tuple, which is the letter and the octave for the bass octave. Okay, so I'm pulling this from these values here, but okay. This one is $0.05. Okay. So these two parsers produce a pair, and this one produces a list. Okay. And then let the note parser equals, well, it's accidental parser followed by this is really lowercase. Followed by this or that. Note lower. Followed by, I think that looks better down here. Okay. Followed by the octave modifier parser. Okay. So this, well, I think it is used now. I should only be complaining about this one. Let's make sure. Consecutive statements on a line. What do they do? Parentheses. Okay. Well, that gives us a place to stop. So what we've done is we've defined a new parser function based on this that we should be able to use down here. We haven't used it yet. We've just said, okay, there is a parser. The way to match a note is to match the accidentals, either an upper or lower letter, and match the octave modifier. And we've, if we did that, we need a routine to semantically put together a note, and then this thing can return a parse result with a note in it. All right, so we'll pick up there next time, which is tomorrow, Wednesday. The time will be 1 to 3:30 p.m. Eastern Time, or 6 to 8:30 p.m. UTC. And I think we will continue with the parser and switch this over to using that. And once we have that, I'll go ahead and switch the other parser, which was just matching a bunch of notes, just from a big string. I think that'll integrate nicely. And with that, we'll have a representation of our notes. I think we've got a little bit of stuff to do in terms of like validation and some other things. And then we'll be ready to look at the keys, which is a pretty complicated thing in here. I don't know why it's quite as complicated as it is, but let's see, key. Yeah, we have this table of, I think I calculated 105 keys definitions, and then also we have altered key definitions or explicit key definitions. So we've got a bunch of ways to match key signatures, and we'll add those in as well. And once we have those, we can talk about, if I tell you it's an F and you know it's in the key of G, it's really an F sharp, and all that kind of thing. I think our representation will be fully separated from our ABC notation, and you'll still be able to do this Parsons code matching that says, turn these into strings of downs and ups. So again, thanks for joining, and take care. I will see you tomorrow or in the future, I hope. Bye-bye.